Chaos, panic, total devastation. Asteroids in films are pretty scary. They tend to appear out of nowhere, sending fictional astronomers and governments scrambling to somehow fight the apocalyptic threat. But off the silver screen, we have things under control. Well, sort of. What would happen if an asteroid came hurtling towards us for real? In films, we tend to catch cataclysmic asteroids only at the very last minute. And Earth is saved in the nick of time by some super unlikely heroic mission. In real life, astronomers are constantly keeping a close watch with their telescopes, scanning the sky for moving specks of light that might be rogue asteroids. Space agencies like ESA and NASA maintain a catalogue of potentially dangerous asteroids, and these are tracked by astronomers for years, sometimes even decades, before they get anywhere close to Earth. We think that we're tracking about 90% of all asteroids that might be devastating on a planetary scale. That means anything that can get within geostationary orbit of Earth and has a diameter of more than about 1 kilometer. But what about smaller asteroids? Anything with a diameter above about 100 meters would be big enough to cause significant damage, especially if it were to hit in the middle of a city. And worryingly, these smaller objects, such as the asteroid 2024 YR4 that was in the news earlier this year, are very faint, meaning that they can escape our gaze until they get uncomfortably close. When a new asteroid does surprise us, we need to calculate its orbital path as quickly as possible to see if and when it could hit us. Large telescopes like ESO's VLT are particularly useful for this because they can track faint objects far longer than smaller telescopes. Anything with a non-zero chance of hitting us in the next 100 years goes on a risk list, and right now ESA's list has around 1,800 space rocks on it. But I can reassure you, none of these asteroids have a strong chance of hitting us anytime soon. If we do find a sizable asteroid that is potentially threatening, which means it has a more than 1 in 100 chance of collision, an alarm bell is rung by the International Asteroid Warning Network. This organization, which ESO joined in 2015, oversees detecting, monitoring, and analyzing threats from space, and judges how dangerous they may be. The dangerousness of an asteroid depends on its chance of impact, its composition, and critically, its size. An asteroid just 10 meters across would release as much energy as the Hiroshima nuclear bomb upon impact. That sounds like a lot, but actually these very small asteroids are not that dangerous because they tend to mostly disintegrate in the atmosphere. However, the energy released by an asteroid increases proportionally to its size, cubed. This means that a 100-meter asteroid would release 1,000 times as much energy as a 10-meter asteroid, and is at the lower limit of what is considered a major threat. A 100-meter asteroid could level a small city, risking potentially thousands of lives. Worryingly, we only know about a third of nearby objects between 100 meters and 1 kilometer, but we're working very hard to find the rest as quickly as possible. Imagine that we do detect a threatening asteroid about to hit us. What can we do? Strap Bruce Willis to a rocket and have him blow it up? Well, not quite. But all those asteroid disaster films will write about one thing. We would need to organize a space mission. The earlier, the better. There is even a UN-endorsed group in charge of advising and coordinating this, the Space Mission Planning Advisory Group, which ESO also has a seat on. This group has run several detailed planetary defense exercises and was activated for real for the first time earlier this year, when it looked like YR4 could be a threat. Unlike in films, a real planetary defense response probably wouldn't involve destroying the asteroid, because breaking it up into thousands of smaller pieces would cause these to rain down on Earth. They would be impossible to track and could still be large enough to cause serious damage. However, we have other options, which are equally spectacular. One would be to spray paint one side of the asteroid white. This would cause that side to become more reflective, causing the energetic photons from the sun to bounce off it and steer it ever so slightly off course and just miss us. Another option would be to send up a space mission to move the asteroid away from its path of collision with Earth. Sounds like science fiction? Or actually, we've done this before. In 2022, the DART mission successfully deflected the asteroid Dimorphos off from its predicted orbit. The VLT played an important part here, watching carefully as the space probe hit a perfect bullseye on the asteroid and analysing the material released by the impact. Dimorphos was completely harmless, but an important testbed, thanks to which we now know that humanity can directly intervene in the event of a serious asteroid threat. But we need to act early enough, because the further away the asteroid is from impact, the more effective these methods are. As things stand right now, it looks like we won't need to deflect a threatening asteroid anytime soon. But this could change. And when it does, things may not pan out like in your favourite action film. But rest assured, astronomers around the world will be ready, with telescopes, space darts, and giant bottles of spray paint.